This is the session on data slicing, and so we're going to see 3 good presentations on it. The first one will be by Dwight Beaver and Sean Hutchinson, and Dwight is a member of the CERT group at Carnegie Mellon University. He works in the system integration work coming out of Washington, D.C. And Sean is a graduate student at University of Pittsburgh that's been serving as an intern. So, without further ado.
Glad to see so many people made it from lunch and are here. This is going to be interesting following lunch and the great keynote speaker. So, without further ado, our talk is going to be about Elasticsearch, Logstash, and Kibana, like the title slide says. This is our disclaimer. Basically, this says that CMU isn't responsible if this presentation kicks a kitten or makes a unicorn frown. So whatever you take away from this, Carnegie Mellon is not responsible. All right, so who am I, who are we, and what do we do? So my team, which consists of 5 people, runs a prototyping lab for one of our customers. Basically, within our environment, we get hardware and software, and it comes in kind of ad hoc, and we do different kind of accreditation, testing, and those kind of things. Our lab is a pretty large space. It can accommodate a lot of different hardware and a lot of different software coming in. So what are the problems we run into? So this talk is going to be more about operations as opposed to earlier this morning. So most of my problems are operational, right? So I have a small team. I have 5 people. Of those 5 people, I don't have all their time. I might only get 75% of their time some months, right? So I have to rely on automation. I have a lot of users coming in and out of my environment. So these are users that I don't trust. Basically, to get into our environment, you have to sign this nice rule of behavior, say you're not going to do anything bad. We give you a VPN account, you install it on your local machine, and you're in. So it's pretty ad hoc who can come in. We also have a lot of systems. At any given time, we might have 100, 200 different users that have an account. 30 or 40 of them might be bringing in systems or having virtual machines generated. So this generates a lot of operational data. Everything from network flow to like session data to logs, and we're concerned about all of it, right? I'm concerned for the whole spectrum, security down to why is my DNS server slow or something like that. So lucky for us, we have no sensitive data, so we don't really have a lot of PII concerns. Pretty much our only informational concerns are, we have an Active Directory, we have our users' names and emails. But other than that, there should be no production data, there should be no sensitive data coming into our environment. However, we're not, as the picture shows, we're not allowed to use anything with the cloud. So a lot of what we do would be great if we could automate it and put it in something like AWS for like our monitoring and that kind of thing, but we can't do that. We're stuck using stuff that's physical, it's in our environment. All right, so this is the Python script that we have to use. So basically, you insert operation, you have a small team. Our task is do detection with security teams set to false. We need to maximize watching cat videos and react to different events coming in. So that's basically what we do. All right, so when we started standing up our operational cluster, let's call it our SIEM-like thing, or SIM-like thing, we looked at a few different options, right? So we looked at doing something with Hadoop, we looked at using Splunk, and we eventually came to choose Elasticsearch. And we specifically came to Elasticsearch, one, because Splunk could probably do what we want to do, but it's expensive, right? And we wanted the ability to add as much data or take away as much data as we wanted. We want to put operational data in, we put network security data in, we want to be able to put in data and not worry about our licensing. So Splunk was out. Hadoop would have also worked, but it has a much higher learning curve. Deploying Hadoop infrastructure and then actually getting useful things out of that takes a little more expertise than something like Elasticsearch. So we decided on Elasticsearch mainly for these reasons. It's easy to deploy. So with Elasticsearch, you can go to the website right now, download a jar file, unzip it, run it on your local machine, and you can have an Elasticsearch instance running that is listening on the local socket, and you can query it, add data to it, do whatever you need to do. Now, to get that deployed in a distributed environment where you're receiving more data, it takes a little more configuration, but for our cluster right now, each one of the configuration files is roughly 10 lines. So the configuration is pretty standard. And it's very, it's also, as a Unix guy, it's nice to be able to read a configuration file and know exactly what's going on. It's not like trying to configure sendmail or something ridiculous like that. Also, it vertically and horizontally scales, so we can add bigger nodes and it's going to get better performance, or we can add more nodes and we're going to get better performance. It also has an easy-to-use API, so it's RESTful, so you can interface with it using something like curl. That's pretty basic, though starting out, a lot of people just use curl. But pretty much every programming language out there has some kind of library for Elasticsearch, and it makes it very easy to interact with the database, add things, query, do facet searches, all those wonderful things. And finally, one of the biggest things for us, since it's free, is that it's heavily developed right now. So there's a lot of buzz, especially in industry, about using it for like e-commerce sites, looking at their data, searching, those kind of things. So there's a lot of people asking questions, there's a lot of people responding to questions, and a lot of people on IRC that are willing to hop in and help you out if you have any questions. All right, so I only have 30 minutes, so I can't really go into great detail about how Elasticsearch works, but to give you the quick rundown, the things you need to know is there's this concept of an index. Basically, an index, if you come from the relational database world, think of it as just a database. Within the index, an index, like an example we use, like we have log information coming in. So we have an index for each day's logs. And within that index, each document, which is a set of key value tuples, will have a type associated with. And you think of that type as a table in a relational database. So basically, if I want to look, say I have an index that has, Cisco router information, syslog, and Windows event log, I can throw that all into my logging index, and then I can filter on the type, and it's kind of like querying that table. And then I can run different queries about the data which is in that specific type. Indexes are broken into shards. Shards are distributed amongst multiple nodes. And you can think of a shard, if anybody's familiar with Lucene, it's basically an individual Lucene instance. So your index is split into shards or distributed, which are each kind of providing, or basically running Lucene on the back. All right, so pretty much our hardware and infrastructure is pretty basic. So we took what we already had, right? So we're a prototyping lab, so we have a lot of resources for virtualization. So we have blades, we have network attached storage. We also have aggregate taps for different uplinks and physical links within our environment. We use that to collect some data. We also use, since we use heavy virtualization, we also do a lot of virtual networking. So we use VMware's ability to mirror certain ports for different high-value servers. So like our Active Directory servers, our DNS servers, maybe our Puppet server. We're port mirroring that to a sensor so we can look at the network traffic coming into those. And finally, I can't emphasize enough when you're building something like this, really look at using something like Puppet. So for you not familiar with Puppet, Puppet is a tool that allows you to define configuration in software, and it basically does constant configuration management on different Linux boxes within your environment, and it's great. So we basically define what our cluster is supposed to look like, what a node configuration is supposed to look like, and then we can easily deploy a new node or do auditing to make sure that nodes are consistent throughout our cluster. So, all right, so, and this is our physical breakdown. We just recently expanded from 4 nodes to 8 nodes because we were actually, our Java heap on our 4 nodes was hitting like 99% utilization. So basically we have 8 nodes, 4 cores each, 16 gigs RAM, 500 gig data partition, which is on NFS, and pretty much everything is deployed using Puppet, and specifically the Puppet Forge module, for you familiar with Puppet. Its Elasticsearch module is really good. So, all right, and so for software, once getting away from Elasticsearch, we use Logstash for data aggregation. So what Logstash does is we installs an agent on multiple nodes, and it can collect different things that it has an input for. We have it running on all our Linux boxes. It collects performance data using collectd as one of its inputs. It also, as an input, uses syslog, and if we have a few other inputs. And so basically, it takes that information, puts it on a queue. We use Redis because it's just easy, but you can use ZeroMQ, RabbitMQ, whatever you're familiar with. Logstash has an output for multiple queues. And then from Redis, we have another Logstash instance that reads the queue and then puts it into the Elasticsearch database. For anything that we don't have an input for, so Logstash doesn't know how to natively read that data type, we use Python. So we do that for Silk data. So I collect Silk binary data on a central server after I insert it into my Silk repository. And then I have a Python script that reads through that, puts it on the queue, and then puts it in Elasticsearch. And then Kibana, Sean is going to go into what Kibana does, but it basically provides a very easy way to visualize the random data that you're throwing into this thing. All right, so these are our data sources. It's pretty typical operational data. Windows event logs, syslog, Bro. We're using Silk, SNMP, and we're also now doing full packet capture for 20 days. And Emily, who's back there, she's our YAF developer. She's put a lot of time into making YAF do rolling PCAPs and indexing of PCAPs. And so we've been testing that, and we've had a lot of success with that. So now we're capturing PCAPs, is keeping metadata that we're storing in Elasticsearch. So now you can actually go and look at flows in our Elasticsearch, see like the hash that you need to pull out the PCAP, and then pull up the PCAP that relates to that flow. So it's kind of new, but it's kind of cool. So just thought I'd shout that out. All right, so for all you manager types, this is a Visio I made. I'm pretty proud of it. It has boxes and it has arrows, and it kind of shows what we're doing. So Donovan, my manager, is really proud of this, so I had to show it. Yep. Middle management written all over me, right? So, all right. So basically, these are the things that we're going to do, and Sean is going to get up here and he's going to talk about some of these things, how we're doing them. But we can do batch analysis, retrospective, kind of like what you do with Silk. We can also do correlation, either using the Kibana web interface or mostly using Python scripts or whatever we have available R. We can make pretty graphs for displaying on TVs, which are very, very popular with Donovan. And we can do alerting with things like Python and R. All right, and so this should be where we want to go, not do. It's actually let's go upside down. But this is kind of what we're thinking, right? So we really like Puppet. So as people that run a large lab where things are moving pretty quickly, like being able to automate deployments and making sure things are consistent is great. We're also collecting all this data, right? There should be some way for us to look at how we're defining our nodes in Puppet and then do continuous auditing off of the data we're collecting. So that's kind of, as we get this thing stable, that's kind of what we're going to be looking at over the next 6 months. Can I define how my nodes are communicating within my environment? And then can I automatically, based on the configuration for Puppet, which I store in Git, which is version controlled, can I see anomalies? So that's kind of where I'd like to see this go, and maybe we'll have a talk next year about that. But without further ado, Sean's going to come up and kind of talk about how we're actually using some of the operational data. But please, I know we don't have a lot of time, but if you have any questions that's interesting, please find me or send me an email. So.
Thanks, Dwight. Hi, I'm Sean. I'll just get right into it. So we can do batch and retrospective analysis with Kibana and scripts. We'll start with the actual Web GUI. A simple use case is, say we see some interesting traffic coming from one of our servers. We want to know which processes were run around that time. Typically, you'll just set like a simple time range. You already have the type in there generally. So the event log ID for processes is 4688, and then we can set our host. This is generally what we'll use in the Web GUI. You just see a nice table with a bunch of fields and tells you basically all the relevant information. And you can use the logon ID to correlate with other Windows events, which I'll go into in a second. So for the batch analysis, I typically like to use the Python API for Elasticsearch. There's a lot of query and filter options, and it's really flexible. So you can do like Boolean queries, and you can do should not, must do, must not get, and then you can nest as many as you want in those, and it makes it really flexible. The scripting is essentially good for running queries on demand over any period of time, which I'll show an example of. Checking on important events that are too cumbersome to alert on, like registry modifications. Like you could have a list of places that you want to check in the registry, but there's so many of them that you're better off just looking at all modifications. Daily review of logs. It's pretty simple. Just come in and say, hey, what happened in the last 24 hours? And then you can, it's pretty easy to quickly write up a query and investigate anything more specifically. So there's a couple different Python APIs for Elasticsearch. Dwight was using another one that I wasn't using, and it probably looks different. But this is an example of the queries that you can write for the API that I was using. And so the source just contains all the fields that you want returned back to you. And then you can see there's queries and query and filter blocks. And I don't know, it's pretty straightforward. You typically want to query or filter on one or two fields and within a certain time range. But the assumption here is that you know what fields you're looking for. So you kind of have to know the data and what data you're getting in and what they're called. So this is an example of one of the batch scripts that I wrote. It just checks for object access on audited file systems and registry modifications. And it'll basically, these aren't the queries, well, actually, these are the queries for that. But it'll probe Elasticsearch, and I just kind of loop through the result and spit out the relevant information that I'm looking for. And here we see, I have it split up into accesses to audited file systems by user service accounts, which are more important typically than ones by computer accounts. Somebody accessed the security log, that might be something suspicious, and then you have the login ID there for you to correlate with like a user session if you wanted to. And then we see there was a registry modification. Somebody changed one of the startup folders to execute evil.exe. Kind of have the same information that you can use to correlate with, to investigate that further. Typically, for registry modifications in particular, the computer accounts will sometimes show, but you really only want to see maybe a small set of processes that do modify the registry, and those will typically be associated with like updates or something. Correlation of data sets and visualization. So Kibana is really good for, it's promoted as a visual analytics interface, basically. And part of what I did was create dashboards. One in particular, which I'll show, is for the all the bro data, and then one for all the silk data. It kind of depends on how you build the dashboard, and it's fairly flexible. I think the scripting is a little bit more flexible, but you can use that to just stay within your browser, open any number of dashboards, and depending on how well they're set up, you can do some pretty decent correlation and get a lot of information just by looking at graphs quickly. And so I like it because you can just do a simple filter, and then you get a bunch of information from all the facets that you create. And I'll explain that. So this is a snapshot of the bro correlation panel. And I haven't expanded any of the rows that you see there with notices, connection, session data, DNS. So those are all just examples of different bro logs. And for each of those rows, you attach a query so it specifically looks at like bro notice logs or bro DNS logs and none of the other ones. And so you can have them all expanded at the same time if you want, and it'll only show the relevant information for those logs. Another cool thing is you have these, a common thing too is these histograms, and I like to use the pie charts to sort of just offer a little bit of summary data and like what logs are receiving the most proportion of the records. So when you apply a filter, it filters for the whole page and all the data that is available for input on that dashboard. So if I filtered for well, I guess say like an IP address, and didn't have any of these expanded, you could see just by looking at the logs by type which logs had records associated with that IP address. So it's just kind of just real quick and like what time, and then you can dig into it more after that. Another example is our Silk panel, and again we have just a straightforward histogram, some bar charts and some pie charts, but one reason I really like this is it's basic, but if you just give it like an IP address or one or two fields, which is real easy and quick, you get a bunch of information pretty much straight away, and just by looking at the charts. And for instance, like what applications and services, what flow type is it generally using, top destinations, like top 10 destinations, top 10 sources, depending on what you're filtering on. And below that, there's more. I didn't take a snapshot of that. But, and those are all arranged by bytes. One thing with the Kibana facets is you can really only do charts like this based on maybe 3 variables. So it'll give me, like for instance, these pie charts. It'll give me top 10, which you can change the number of results that you get back, but top 10 is fine. Top 10 destinations out, for instance, and that is arranged by descending order according to the most amount of bytes sent. So it's really just, it's kind of limited in that fashion, I believe. Another thing you can do with Elasticsearch, and this is where more of the scripting comes in, we used Elasticsearch to just give us some basic email alerts on some Windows events that we wanted to know about pretty much right away, or as soon as possible, or as close as to when they happened. Some of these are administrator login, local account login attempts, because we're in a domain, we shouldn't really see too many of those. User account creations, security group creations, scheduled tasks, log clearing. We'll just go through some examples of that. They're pretty straightforward. And I believe you can do these, you can kind of get the same functionality in other ways, but the focus here was to leverage what we could do with Elasticsearch and all the data that we were kind of getting in one central location. But this is just Windows stuff. So I have like the usernames and hosts blocked out, but you can get the picture. So-and-so added, some user to global group, some group in the domain. User account management events is just user creation, user, if you enable a disabled user. Here's an example of local account logon event, and there's a number of different error codes associated with those. Shouldn't be too many successful validations. That means a user is logging in locally on a machine. You might want to check that out. And then anytime a log is cleared, probably want to know about it. This is another example of local login accounts. And so every once in a while, I think Nessus does like random scans. I'm not sure when it actually goes off, but Every once in a while, you'll see a bunch of these local login events, and typically you can identify if it's Nessus because it'll have these random usernames or EXE single character usernames, and those should all happen, right at the same time, which is typically the case. But if it's not Nessus, then you'll definitely catch maybe some local brute forcing or anything like that. Administrator login events tells you what processes were associated, login ID, login type. So we see like a network attempt and a couple RDP logins. Windows tends to fire off multiple events for one action, which can be kind of confusing. Scheduled tasks, alerts. It's kind of just basic information again. This isn't like the whole message. I just tried to pull relevant stuff from it so that we could proceed once we said, hey, somebody shouldn't have created this. Typically, you use the login ID. Another thing I did was I used the scripting to pull data to alert on irregular login activity. And the basic idea behind this was to keep an eye on privileged account use. And we wanted to know when users logged into hosts they never or rarely logged into, any attempts from atypical source IPs, or whenever the login activity violated certain thresholds. So basically, I would just query Elasticsearch. Well, the alerting mechanism works just like the Windows alerting mechanism, and that'll query like every 4 minutes, 15 times an hour. But the way we get the data and then eventually alert on it is we'll pull 24-hour login stats or login information, and then we process that with R. It spits out a nice email that our team can look at in the morning and see any activity that happened in the last 24 hours, such as logging in at 3 in the morning or something. And it gives just basic stats and some basic plots on user activity and host activity associated with logins. The way we populate the database to alert on irregular login activity, like I said, we'll get all the stats for 24 hours, and then we won't do any kind of combining quite yet, and we'll just do that for a week. And then I have a script that uses that to spit it into R, and that'll kind of mess with the data set and deduplicate it, and that eventually puts it into a database. So they're just unique values associated with, like, say, a user and a host or a user and an IP. And then I assign those associations weights. And typically, if it's a low weight and they see somebody log in, then it'll alert on it if it's above a certain weight that I've set, kind of arbitrarily. But it's a new implementation. I'm kind of playing around with it. So those are things I work on. Here's an example of the message in the email. It just says, hey, this guy logged in after 8 p.m. Well, actually, this one was before 6 a.m. I selected those hours just because nobody's typically around before or after those times. And these are some of the plots, the information included with the email. It's just the range of hours seeing logins per host, per method, logins per user. You see a user logged in 22 times, which is abnormal. The unique source IP addresses per user using RDP, which is pretty normal. That red dotted line indicates my chosen threshold at 3. If you're logging in from kind of 3 or more machines, I might take a look at what's going on there. And then we're just seeing the unique source IPs per user for SSH. And then it shows, it'll do a graph like the one on the right for any time somebody does hit that like that IP address, source IP threshold, and it'll tell you what host they logged into from what IPs and how many times. Some examples of the alerts from this activity is, secure shell user so-and-so, never seen before, hasn't logged in for 2 or more weeks. And it gives you the IP and the host associated with that login. Or, so then you see U2S is user to source IP. Those are just regarding user to source IP associations. And it's not in the database because the user never logged in with that IP before. User to host low weight, it's user and host association. They rarely logged into that host, so it might flag that. And then, like I said, I'm playing with those thresholds. I think that's it. Any questions? Thanks.